Dear students, in this class we are going to be discussing about the chemical properties of alcohols. These chemical properties of alcohols either by the cleavage of the CO bond, that is the cleavage of the CO bond or the cleavage of the OH bond. We know that in the alcohols OH group is a functional group. OH group is a functional group. Therefore, the involvement of OH group in the chemical reactions. These alcohols undergo substitution as well as elimination reactions. This undergoes the substitution as well as the elimination reactions. This alcohols it acts as a both nucleophile and it also acts as a both an electrophile. That is, it acts as a both that is a nucleophile. Sometimes it acts as a nucleophile. Sometimes it acts as a that is an electrophile in some reactions. That is the reactions. The first we are going to be discussing about the how it's going to be acts as a nucleophile, how it's going to be alcohol acts as an electrophile. Means the first that is a nucleophile. The alcohols act as a nucleophile. Nucleophiles. That is nothing but cleavage of OH bond. Cleavage of OH bond. Cleavage of OH bond. In this, there is alcohols. Generally, we are going to be represent like this. The alcohols we are going to be represent like this. In this, it is going to be acts as a nucleophile. Nucleophile means electron-rich species. This is going to be react with the electron-deficient species. Electron-deficient species is going to be react with the electron-deficient species. At that time, it is going to be formed that is a intermediate compound. That is a C. That. Then this on deprotonation we are going to be get that ROC. Then this we are going to be get the product. Then so next alcohols acts as electrophiles. Alcohols acts as a electrophile. Electrophile. How it acts as a electrophiles? That is the cleavage of CO bond in this. That is the cleavage of CO bond. The cleavage of CO bond. There is the first one is alcohols acts as a nucleophile. React as a nucleophile. Then alcohols acts as a electrophiles. Electrophile means that is the deficient species. Electron deficient species. In this, that is, if you are going to be taken that alcohol, generally we can be written as RCH2OH. This is going to be protonated. You are going to be get that some addition product, that is the OH twice. This is the electrophile. This or there is a nucleophile. One of the nucleophile is going to be reacts with the that is a electrophile. It's going to be reacts with the electrophile. That is a plus species. Then it's having the plus here. Then it's going to be removing the H2O molecule. We are going to be get that is RCH2 Br plus H2. In this, we can say that is it acts as both as an electrophile and the nucleophile. In this case, it acts as a nucleophile. That is the cleavage of the OH bond. That is the cleavage of the OH bond. In this case, the alcohols acts as a electrophiles. We'll see some examples for this. That is reactions with the metals. We are going to be discussing now reactions with the metals. That is reactions with metals. Means how it's going to be reacts with the metals, that is alcohols having the acidic nature. The acidic nature, due to this, alcohols is going to be reacts with the metal like sodium, calcium, aluminium, potassium like this. It is going to be formed the corresponding alkoxides. It's going to be formed the corresponding alkoxides. If you are suppose we'll take with the sodium, we'll take the example with sodium with Na. How it's going to be react? Means that alcohols having the acidic nature. That is we are going to be represented by the alcohols ROH. That is ROH. This is going to be reacts with the sodium. This is going to be reacts with the sodium. That is alcohol reacts with the sodium. It's going to be formed the corresponding alkoxide. That is sodium alkoxide is going to be formed. That is 2RONA. This we call as a sodium alkoxide. This we call as a sodium alkoxide. Plus with the liberation of hydrogen. This is the sodium. If these alcohols reacts with the sodium. Why it's going to be alcohols reacts with the sodium? Because the acidic nature of the alcohols. This is going to be, that is alcohols reacts with the sodium. It's going to be formed that sodium alkoxide with the liberation of hydrogen. If you are going to be taken with the calcium like I told you, that is with calcium. If you are going to be taken the calcium, that is we'll take some example in this case. That is C2H5OH. That is ethyl alcohol is going to be reacts with the calcium. Is going to be reacts with the calcium. It is going to be formed that is C2H5O Ca. It is twice Ca with the liberation of hydrogen. Means calcium, that is alkoxide is going to be formed. This about that is the calcium. Here alkoxide generally we are taken that is ethyl alcohol. Therefore this calcium ethoxide, this we called as the name of this compound we called as a calcium ethoxide. This about with the calcium, that is means the sodium, the acidic nature. We can say that the reactivity of this acid reactivity is going to be, acidic nature is going to be decreases. That is CH3OH is more acidic than primary alcohols, and primary is more acidic than secondary. Secondary is more acidic than the tertiary. Why the reactivity series is like this? Because that the electron releasing groups that is present in the alcohols increases the electron density on the oxygen atom. That time it is little difficult to break the OH bond. Therefore, it is going to be methyl alcohol is more acidic than the primary alcohol. Primary alcohol is more acidic than the secondary alcohol. Secondary alcohol is more acidic than the tertiary alcohol. If like this only, if you are going to be taken the tertiary butyl alcohol is going to be reacts with the aluminium. It's going to be formed that aluminium tertiary butoxide is going to be formed. That aluminium tertiary butoxide is going to be formed. If you are going to be taken the example, like that only we will take some example. We will write the reaction here. Then, if suppose this is a like in the white reason tertiary butyl alcohol. This is about the tertiary butyl alcohol. This having the 3 number, we will take that 3 number tertiary butyl oxide with the reacts with the aluminium. It's going to be formed that is a 3 that is CH3, CH3O thrice, that is thrice, then aluminium with the liberation of 3/2 hydrogen, that is hydrogen is going to be energy. This about that is with the aluminium, that is the name of this compound is, that is aluminium tertiary butoxide, like this. There the name of this compound is calcium ethoxide. Their general representation, that's why sodium alkoxide. Like this, it's going to be reacts with the metals. That is, alcohols is going to be react with the metal due to the acidic nature, of the alcohols. Now we are going to be discussing about the esterification. This is an important reaction, so many asked in the examination. That is, esterification means that is the carboxylic acid reacts with the alcohol in the presence of sulfuric acid. In the presence of sulfuric acid, it's going to be formed that ester. It's going to be formed that ester. Is called as esterification. That is generally, that is we are going to be written, that is carboxylic acid is RCOOH. This carboxylic acid is going to be reacts with the, that is alcohol. It's going to be reacts with the alcohol, that is R-OH. That is reacts with the alcohol, that is it's going to be formed that is in the presence of concentrated H2SO4. In the presence of concentrated H2SO4, we are going to be formed a ester. It's going to be formed that ester, RCO R' plus H2O. That is plus H2O. This reaction we call as esterification. This reaction we call as the formation of ester by using the carboxylic acid and the alcohol. That is, we will take some example for this. We will take some example. That is ethanoic acid. Ethanoic acid is going to be treated with the methyl alcohol in the presence of concentrated H2SO4. H2SO4 is going to be formed that methyl acetate. That is CH3COCH3. That is plus H2. This reaction we call as a formation of ester. This is the ester. This is the alcohol. This is about the carboxylic acid. We are going to be this about the esterification. Like that only we will discuss about the acetylation. That is acetylation. And this also, that is acid chloride. That is RCOCl. That is we call as acid chloride reacts with the alcohol. In the presence of pyrene. It's going to be formed that ester. It's going to be formed ester plus HCl. It's going to form that ester and the HCl. Then this we'll take that. This is about the acid chloride. Acid chloride reacts with the alcohol. It's going to be formed the ester. And this only will take some example for this. That is acetyl chloride, CH3CON. That is acetyl chloride reacts with the methyl alcohol in the presence of pyrene. in the presence of pyridine, that we are going to get that CH3 COO CH2. This metal acetate plus HCl means this pyridine is going to be used in this reaction because the HCl formed during the reaction get neutralized by the pyridine. This about the acetylation.